In this section, we're going to revisit linear motion. And the big question of this section really is, can we take information about velocity and reconstruct what's happening with the displacement or the net change in the distance, right? So let's take a look at this first example now. This is one that you could do without any calculus, right? Because you drive a constant rate of 60 miles per hour for 2 hours. How far have you traveled over that time? Well, what does 60 miles per hour mean? That means for every hour we travel 60 miles, right? So I could graph, I could graph um, what the displacement over time looks like, right? If we start at 0 and let's say 1 hour is here and 2 hours is here, right? So let's say 60 miles is here, and then 120 is here. And so then, we start out and we travel over the first hour, we're at 60 miles, and then we just continue for another hour, and we're at 120 miles by the time we're done. So you can see that the displacement function is just essentially, it's just 60 times the time, right? Multiply the rate times the time, and you get the how far we went, the distance or the displacement. All right, so that's easy enough. Now I want to do one more thing, because like I said, we're looking at how can we take information about velocity and get information about the displacement. So I'm going to graph velocity versus time. All right, now that sounds like it wouldn't be very interesting, right? Here's 60 miles per hour, right? 60 miles per hour over 2 hours, let's say. What does that look like? Well, we're driving at a constant rate, right? So the velocity doesn't change. It's just a horizontal line. It's a constant. That's a constant velocity, right? But what I want you to notice here is that this area, the area that's formed, that's bounded by the axes and the graph of the velocity, is the distance we traveled, right? The length is 2 and the height is 60. So this area is equal to 60 times 2, which is 120 miles. Okay, 120 miles, 60 miles per hour for 2 hours. So that's the key thing I want you to notice, is that the area under the velocity curve is the displacement. All right, so you can write that down. The displacement is the area between the velocity graph and the horizontal axis. Okay, so it's just this area, the area of this rectangle here. So these first few examples are going to involve constant velocity, right? They're going to involve the idea that if we have a constant velocity over a period, that we can just look at the area between the graph of the velocity and the horizontal axis to determine the distance that we covered over that time period. Okay, so I'll meet you in the next video for the next example.